Hello guys, and in today's lesson we will be talking physics, circular motion. Now, to get straight into the lesson, number one, we have two cases in which a question about circular motion can be asked, the way it can be presented to you basically. As you can see here on the left, we have our case number one, which is circular motion on top of the surface. So in this case, as you can see here, on a roller coaster, you'd be going on top of it, right? And our second case here is when it's moving inside of the circle. So again, you'd think about a roller coaster, on the underside of the surface, basically. Now, the most important thing about circular motion is that there is always a constant velocity, as written here. Now, as we learned before, what does a constant velocity mean? It means that there's zero acceleration. But for everything else, that is correct. But specifically for circular motion, that does not apply. Because now we have something called centripetal acceleration, as labeled here, and as a variable, it is shown as AC. So that's how you'd write it in a formula. And now you can calculate AC using v squared over r, which is the radius. Now, of course, every single circle has a radius, right? And you can find out AC, which is our acceleration, by using this formula right here, which is the centripetal force equals the mass of the object and the centripetal acceleration of the object. Now, to move on, we have a circle here, right? A period is the total time that it takes, that the object travels in, so basically total time. And one trip around the circle would be one frequency, and the variable you'd use in the formula is nu, shown like this. Now, the circumference, as we learned in basic geometry, of a circle is 2 pi r, and that is also equal the formula for our distance around the circle, basically, which is the circumference. Now when we move on, we can look at a few variables that we use, that we can find in circular motion. Now we have t, which is our total time, which is our period, calculated in seconds. 2 pi r, which is our distance, can be calculated in meters. The frequency can be calculated in hertz, and our centripetal acceleration, as you know, is calculated in meters per second squared. Just a little bit of a explanation on those. Now, these, if you want, pause, take a screenshot. These formulas right here, everything you need for a test on this. Basically, you have v equals 2 pi r over t to find out our velocity if r and t are given. To find t, we can do 1 over f and switch them around to find our f, which is frequency, over equals 1 over t. And another way to find velocity if our frequency and radius is given instead is v equals 2 pi r f. Now to find the force, which is Fc, equals mac, as we saw over there, and our centripetal acceleration, as we also wrote up there, is v squared over r. Again, if you want, I can remove the circle, take a screenshot, do whatever you want with this. Basically everything that you need to be able to find out everything in circular motion. And now we will do together one question of this, which is basically a table that will be given to you. 3 variables are given, and we need to find out the other 4. Now, here, this is number 1. We'll do number 1 together, and I will let you guys do 2 and 3 first before we will both solve both of them together. Now, we have mass, velocity, and time given to us. Now, when time is given, I like immediately going to find our frequency first. So let's go over here to the side. 1, and number 1. So we have our time given, so that means our frequency, which is 1 over t. T is 4, so our frequency is 1 over 4. Now, when calculating stuff in hertz, it's best to put it in a decimal, so in the table we'll label it as, we'll also do this in a different color. We'll do red. We'll label it as 0.25 hertz. Just a little thing to keep in mind. Okay, now that we have our T and our F, we can move to trying to find our radius. So now our velocity is given, so we can take that immediately and I would like to take this formula, as it doesn't have to do any fractions or anything. So we take this equation right here, so we do V equals 2 pi r f, and our velocity is equal to 5 equals 2 pi r, and then this would be 0.25. Now, of course, we divide 2 onto the other side. We get 5 over 2 equals pi r 0.25. Now, when we divide 0.25 by 5 over 2, we can just do that real quick here. So 5 over 2, as we know, that's 0.25, so keep change flip, 4 over 1 equals, boom, boom, that's a 1, that's a 2, so this equals 10. So now we get 10 equals pi r, divide pi on to the other side, and so r equals 10 over pi. So now that we've got our radius as well, we can just put that in here, 10 over pi meters. Now we can, since we found our r, we can calculate our acceleration, which is AC equals v squared over r. Now AC, write that down, AC equals v squared over r. AC equals v squared, which is 25 over 10 over pi. And again, do the same thing, keep change flip, we get 25 over 1 times pi over 10. You can divide both sides by 5, you get 2 here, so it ends up being 5 pi over 2. So we can also now write that into our AC. So 5 pi over 2 meters per second squared. And now finally we can move on to our force. Now that is probably going to be the easiest one, as we have both of the variables already that we need to find. So FC, just write it here, equals M, which is 10, times our AC, which is 5 pi over 2. And so our FC, and we can calculate our force, 10 over 1 times 5 pi over 2. That goes, this equals to 5, so we get 25 pi. So our force is 25 pi newtons. That's the first question done. Now if you want, pause the video and figure out questions 2 and 3. Okay, now that we're back, we can start question number 2. Now, for question number 2, we are given a mass of 20 kilograms, a radius of 3 meters, and a frequency of 0.25 hertz. Now, I see one of either frequency or time, and I immediately go to these formulas right here. Easiest thing you can start off with. So we have our time formula, which is 1 over frequency f. So that means time equals 1 over 4, and that is t equals to 4 seconds. So quick and easy. Got that done already. As you can see in question 1 and 2, they are both quite exactly the same. Now, after that, we can find out our velocity with either one of these formulas, since our radius is given and so is our time and our frequency. But let's do this formula right now. So V equals 2 pi r over t. So we can plug those in. So V equals 2 pi 3 over 4. So you just multiply these two, you get V equals 6 pi over 4. And if you simplify it, V equals 3 pi over 2. Now we can plug that in. Let's use a different color. I'll also use a different color for this one as well. Whoops, not this one. This one right here. 4 seconds. And we found our velocity is 3 pi over 2. Now that we found our velocity, we can find out our acceleration. As you can see, it's just a chain of events. You find one thing, you're able to find another, and then another, and it just keeps going on like that. You just have to plug it into the formulas. Very quick and easy. So our AC, as the first formula that we learned, is V squared over R. Now, again, use a calculator for this one because we found our V is 3 pi over 2. So this can be rewritten as 1.5 pi square over, let's put that in the parentheses as well, over R, which is 3. So 1.5 pi square is equal to 22.2 over 3. And our AC is equal to, after you divide those, 7.4 meters per second squared. Remember not to forget your units, and we can fill in that blank in our graph. So 7.4 meters per second squared. And now our last box that we need to fill in is our force, and pretty straightforward. As we know, force equals MA, So that means our force equals our mass, which is 20, times our acceleration, which is 7.4 meters per second square. Oops. And that means our force is equal to 148 newtons. Oops. And just plug that in to our graph, and that is question 2 done and dusted. Now you can pause the video, take a screenshot, and if you didn't work on question 3, work on question 3, and we will be back. And we are back now for question number 3. Now, for question number 3, this will be our work area right here. We are given a mass of 30 kilograms, a velocity of 9 meters per second, and an acceleration of 18 meters per second square. Now, with this, we can find our FC, our force, by doing FC equals MAC. Now our mass is given to us as 30 times our acceleration of 18 meters per second square, and from that we get 520 newtons. Now we can plug that in here. Now that we found our force, we can now figure out our radius. Now we have given to us our velocity and our acceleration, and we can use that to find radius using this equation right here. Now, AC equals V squared over R. Our AC is 18, and then V squared would be 81 over radius. So now all we'd have to do in this situation is divide 81 by 18, which equals 4.5 meters. So our radius is 4.5 meters. Now, the next thing we can do is we need to find our time and our frequency. And to do that, we can use this formula up here. Either one works. We'll just try to find out our t first. We'll find our frequency first. So V equals 2 pi RF. Now our V is equal to 9 equals 2 pi. Our radius equals to 4.5. And our frequency is the thing we need to find out. So we can multiply these two, we get 9 equals 9 pi F. We divide 9 onto the other side, 1 equals pi times F. Divide pi onto the other side. Our frequency is equal to 1 over pi hertz. We can plug that in to our box here. 1 over pi hertz is our frequency, and the final thing that we need to do is just switch it around. T equals 1 over f. So T equals 1 over pi. And so our total time is equal to pi seconds. So we can fill in our final box in this graph. Our total time is equal to pi seconds. And that is it finished. And that will do it for today's lesson. Thank you for listening, and if you have any questions or comments, please let me know. And thank you. Have a good night.